There we go. Now, we were talking yesterday about the arc length. Here's your arc. Arc length is a linear measure that is a portion of the circumference. I could literally take a tape measure and measure around the crust of that pie. That's arc length. When we talk about the actual slice, that's when we're talking about the sector of the circle. And we're able to find the area of that actual slice of pie. Now, we also learned yesterday, or we got started, that arc length in geometry was the measure of the arc divided by 360 times 2 pi r, okay? And that's straight from geometry. We're going to kind of tweak this today. You get your cards finally. Y'all take one and pass it around. Okay, here we go. But in geometry, we have the measure of the arc divided by 360 times 2 pi r. And we determined yesterday that this is, really, it's just a fraction of the circumference of the circle. In geometry, I had some students who never could figure out how to find the arc length, but if you said, find a portion of the, if they would think that way, okay, well, what's 1/6 of 360? And they would go 60 degrees. And they would get it. They would understand it. But what we're going to do is we're going to look at that card, just take a card, they're all the same. And now we're going to start this formula card that you're going to keep with you at all times. You're going to keep it with this class through the end of this class. We're going to add to it almost daily. If you are going on to pre-calculus, I think Ms. Wallace will let you use the card, so keep it, okay? You want to use, I can tell you right now, you do not want to write big, okay? You want to use, some of you, if you're visual like I am, you will want to use different colors of ink. And you'll want this to be as neat as possible because on every test, quiz, whatever you have to do, you're going to be able to use this card, okay? So this is something that's very important and you got to get it right. We don't want to have to white out anything or erase or mark through and make it look crappy. So this is something you got to take good care of. Keep it in your binder. Keep it somewhere. You will find it every single day. You cannot lose this, okay? The first thing I want you to, we're going to take a little side note. First thing on this card, though, that I want you to put, what was the first equation that you found or that we used when we were dealing with the unit circle? Okay. On the card, the first thing you want to put on there is that x squared plus y squared equals 1, okay? And that is the equation for the unit circle, okay? You want to put that somewhere on your card. And I don't care how you write it, up, down, sideways, whatever. Okay, it's totally up to you. We're going to add to this card today, we're going to add 2 more formulas. I would drop down just a little bit from that, maybe go, let's do this. We got our equation for the circle. Now we're not thinking x's and y's, we're thinking what's? Cosines and sines, as it's related to this. So x squared plus y squared equals 1 is also cosine squared theta plus sine squared theta equals 1, isn't it? That's one more thing we can add to our card. You may also put on your card that sine goes with, what's its inverse? Cosecant. Cosine's inverse is secant. And tangent's inverse is cotangent. It's totally fine for you to write all of this. Okay? There are other trig identities that we're going to add to this later, okay? And you may want to just keep this separate if you have a lot of room left on the right side of where you're writing. You may want to add your formulas right up under there or to the side or something, but you'll figure it out. And it's your card, so make it your own, okay? Your name needs to go on that card. Guard this thing. You do not want to have to copy this thing over. It's a pain because there will be a lot. My whole front of the card is covered, and I write small on my card. And that's not even all the material that we're going to be able to finish unless we keep having snow days, okay? Now, the next thing. All right, so let's go back to our notes because we're going to change up the way we think about that arc length. I got started with this yesterday. This is from geometry. And you can see that even on the card, we started with x squared plus y squared equals 1, but then we dropped back and we went into trig mode and we went cosine squared plus sine squared equals 1, right? So here's the thing. If we go into trig mode with arc length, then we're thinking, there's our angle, theta. And we're thinking about our normal formula, which is the measure of the arc divided by 360 times 2 pi r. This is our arc length. That's our normal formula. But in trig, we're no longer really thinking about degrees. We're more thinking along the lines of radians, aren't we? So what can I change in this formula to make it more trig friendly? Take out the ry because it's 1, okay? All right, so I'm going to substitute the 1 and then I'm going to take it completely out. There's something else. What else? Somebody said 360. What am I going to be able to change 360 into? 2 pi. So I've got the measure of the arc divided by 2 pi times 2 pi times 1 over 1, because I can write anything over 1, right? And it's never going to change its value. So how do I determine, I may have one more thing that I need to substitute. How do I find the measure of the arc? It's the same as the central angle measure. Well, according to my picture, this central angle is what? Theta. So I'm not only going to replace 360 or 2 pi with 360, or vice versa, but I'm also going to take the measure of the arc, which is now theta, and I'm replacing the measure of the arc with theta. I replace 360 degrees with 2 pi. I substitute 1 in for my radius. Am I in trig mode now? Yeah, I'm in trig mode now. And now we got 2 fractions we can multiply. You seen anything that we might be able to kind of make more compact, clean up a little bit? Cancel out the 2 pi. Arc length. Heck, what's it equal to? Theta times 1, which represents the what? What does the 1 represent? The radius. Theta times the radius. Because remember, sometimes we're not talking about the unit circle. We're talking about this arbitrary circle. The arc length is going to be equal to theta times the radius. And for whatever reason, because this makes a lot of sense, in our textbook, arc length is represented by the letter S. I really don't know why. But this is what you're going to put on your card right here. All right, and this is, you don't have to put a cloud around it. The cloud represents, this goes on your card. S, this is what you can write. S represents arc length. Theta represents what? The measure of angle. In radians. R represents the what? R represents the radius. Because remember, this could be any arbitrary circle, not necessarily the unit circle. If you're told it's the unit circle, then you're going to know automatically that the radius is 1. But you've got to put S is equal to theta R, which means the arc length is the measure of the angle in radians times the length of the radius. Okay? That goes on your card. Everything that I have in red goes on your card. When you're given these problems, because now we're getting into word problems, okay? When you read these word problems, you're going to substitute what you're given into this formula. That's it. Sometimes you'll be given the arc, well, sometimes you'll be given the angle measure. Sometimes you'll be given the radius. Sometimes you'll be given the arc length and you'll be told to find the angle, okay? Whatever you're given, your algebra rules don't change. You're solving an equation, okay? So look at this. Here's our first example. Find the length of the arc of a circle with radius equals 10 meters. New word. That subtends a central angle of 30 degrees. Get out of the way so you can write that. Find the length of the arc of a circle with radius equals 10 meters that subtends a central angle of 30 degrees. Draw a picture. We got to draw, and I draw the same picture no matter the size of the angle. I always do this. I got an angle of 30 degrees in my circle. Do you guys agree? Okay. What does subtends mean? Subtends means that this arc right here see what I have written here. Subtends means the part of the arc that corresponds to your central angle. Subtends means the part of the arc that corresponds to your central angle. And there's some more information I can put in here. Go back and you read and you say that the central angle is 30 degrees. I put that in my picture. There's another piece that I can put into my picture. What is it? The radius is 10. Okay? That's a good thing. What am I being told to find? Find the length of the arc. Okay, card. Go to your card. What's the formula for arc length? S equals theta r. I'm going to tell you, if you get into a habit of writing the whole formula, you're going to be better off. Now, there could be little twists and turns to these problems. Theta represents our what? Our inside angle, our central angle. But am I going to throw 30 into my formula? Better go back and read your card, because you wrote something on there, or you should have. It's got to be in radians. What do I do? Your angle must be in radians. What do I do? Convert it using that thing, which is what? Very good. Very good. Some of you are going to look at that and you're going to go, oh, 30 degrees. That's pi over 6. You ought to know that from what? The unit circle. But sometimes you have, do you think we're going to give you just these nice, pretty little angles? No. It ain't happening. 30 goes into 31 times. 30 goes into 186 times. Pi over 6. You guys agree with that? That's the first thing you have to do. If the angle is not in radians, you've got to change it to radians. Now, do I have enough information to find my arc length? Do I have S? What does S represent? The arc length. That's what I'm trying to find. Okay? That's okay that I don't know what it is. Do I have my theta? What is it? Pi over 6. Do I have my radius? Yes, it's 10. I'm going to list it as 10 over 1. I've got 10 pi over 6. Do you guys agree with that? Multiply straight across. Now, I want to ask you something. Arc length is a linear measure. That means I could take a ruler, a tape measure, and I could put it around that crust, and I could go, oh, look. It is such and such inches. Have you ever measured anything that was 10 pi over 6 inches long? Or 10 pi over 6 meters long? I mean, what does that ruler look like? Seriously. I don't know, but how could I figure out? I mean, I've never even seen it. Have you seen a ruler that says 10 pi over 6? No. What? I don't think they make those either. You're right, they don't. Somebody probably has, and they're selling it as a novel idea, and it's a stupid idea. But what do you need to do? Folks, all you need to do at this point is get your calculator. Cynthia. I'm sorry. I don't have to simplify, because watch what I'm going to do. I'm going to take, and y'all know I'm a parentheses ninja, 10 pi, and I'm going to use my pi. It's under the clear button in yellow. It's the caret. You have to hit second caret, okay? Divided by 6. Now, are we more likely to find a ruler that is 5.2 meters long or 10 pi over 6 meters long? You do. You make one and you'll make millions, or maybe at least thousands. Hey, what was it again? Let's round it to the nearest tenths place. What would our answer be? 5.2 meters. What is 5.2 meters? The length of that arc, the length of that crust. That's a big pi. Just saying. Okay? What do you think? What's going to be the tricky part in these problems? The part that's going to bite you it's going to bite folks every time. Remembering to change it into radians, okay? Now let me ask you something. If I were to ask you for an angle measure, okay, we're solving for an angle measure, then the number I get out of my formula, is it going to be in terms of radians or degrees? We're going to do a problem in a little bit, okay, that you're going to be given the arc length, you're going to be given the radius, and it's going to say, find the measure of the angle, okay? That angle measure, when we calculate crunch numbers, solve the equation, and we get theta is equal to something. Is that angle theta going to be in terms of radians or degrees? What's it going to be? The formula says it's always in radians, so what you put in as radians, you will get out as radians. But we're going to convert it over to degrees because who thinks in terms of radians? Right. White does. White does. All right. So let's write the next problem. We'll do what we can. Central angle. Now here's the thing, guys. Don't make this more difficult than it is. I never understand, every semester I teach this section, how you can get confused by plugging numbers into a formula and solving an equation for a certain variable. But it's not just the words. Underline it. Underline what you need. A central angle theta in a circle. Don't make this more difficult than it is what I'm trying to say. Of radius 4 meters is subtended by an arc length of 6 meters. Find the measure of the angle in degrees and radians. Ooh, that's a lot of words. Bless you. I agree with you that is a bunch of words. Why did I have to make it so wordy? Okay? My same angle I always draw. I don't care the size. What can I put in my picture? Central angle in a circle of radius 4. That's important to me, right? Put it in your picture. Subtended by an arc length of 6 meters. Where do I put 6 meters? That is the arc. It's this right here, folks. This is 6 meters. What am I having to find this time? The angle. I've got to find theta, don't I? Does the formula change? No, the formula doesn't change. We're still going to use S is equal to theta R. S is equal to theta R. Finish this problem. Seniors, you may go. And then we'll talk about it when you get back from lunch. S is equal to theta R, and we've got, what's our unknown? Theta is our unknown. All right, so our S, arc length is what? 6. And the radius, stop talking because you're being rude. Radius is 4, right? I've got to get theta by itself, so what am I going to do? I'm going to divide by 4. Now, this looks weird because you're going to get theta is equal to 6 over 4. I agree, it looks weird. 6 over 4. That's just 3 over 2 or 1.5 radians. Folks, what is that talking about? And you may have heard my conversation, Dylan and I talking about this right before lunch. 1.5 radians, remember the tick mark circle? That's the 1.5. That's what it's talking about. If you can think, if that's 1, I don't know, and let's say this is the 1.5, that means that it's just the tick mark circle. And I'll admit, the 1.5 radians, it messes with me, but that is the correct answer. How would I know? Not only do we have to find the angle in radians, we've now got to find it in degrees. Now, am I going to use 1.5? If we're converting radians to degrees, I want to use 3 over 2. And I'm going to put this R here just as a hint for me that if I have radians in the top, then my conversion factor has got to have pi where? In the bottom. That little R, let me say it again, that's just a hint for me, for hope, okay? Because that's how I know where to put my pi, in the numerator or the denominator of my conversion factor. Now it's just calculate it. That's all. 2 goes into 2 once. 90, I got, what is this, 270 over pi. Cynthia, thank you. I'm sorry. I have no idea why it won't cut on up here. Thank you. And folks, now it's just a matter of dividing 270 by pi and figure out what that decimal is, and it is totally fine. If we're going to have 1.5 radians, it is completely fine to have approximately 85.9 degrees. So we have our degrees, we have our radians. Have we found what we were defined from this problem? Yes or no? Look at it, think about it. You're probably right. They would probably just go to the farm and get the milk there. Yeah, no, they would just go to Granny's. Here we go. Here's another one, folks. You guys, whenever you feel like it, whenever you feel like doing this. Okay, I'm not giving you the word problem. I'm giving you just a picture. Find the unknown. I want your answer in terms of radians and degrees. Okay? All right, so S equals theta R. S is what? 10 equals theta times divide by 5. Really? 2? What? 2 what's? 2 radians. Good. 2 radians. And now we have to change it 2 degrees, so you got your 2 radians. That's just for me. What's my conversion factor? 180 over pi, which is 360 divided by pi, which is approximately what? Let me see it. Okay, 114.6. Hey, what are you thinking about this? Facile? Hands up? High five. Good. All right, so I'm telling you, don't roll up in here tomorrow and say, I don't understand. Because arc length is what formula? S equals theta R. Arc length. If you're given the arc length, if you are given the radius, if you're given the arc length and the, that's the angle, isn't it? If you're given the arc length and the angle, can you find the radius? Yes. Yeah, y'all are like, what? Huh? Huh? Are you talking to us? Are you teaching? What are you doing? Here's another one. Get your card out. I know. Sector, area of the circular sector. Remember, this is the slice Okay? Read the problems carefully and determine what you need to find, okay? Here's what you're going to be given. Let's go geometry first. And then we're going to take what we know from geometry and we'll apply it to trig. No. No, this is in your notes. I will put a cloud around your card. Oh, I faked you out, didn't I? Ha ha. Y'all kill me. Here we go. Central angle is the same place. The area of the sector in geometry was the measure of the arc divided by 360 times pi r squared. So it was a portion of, because the measure of the arc divided by 360 is just a portion. A portion of, what's pi r squared? It's the area formula. It's a portion of the area. That's the formula we used in geometry. Now, in trig, we're thinking not degrees, we're thinking what? Radians. Okay? Think radians. Think radians. Now this is the way I think, or I write the formula. I write A sub S, meaning area of the sector. That's nothing technical. That's a Miss Perry thing, okay? The measure of the arc, though, in trig, when we talk about that central angle, we're talking about what Greek letter? Theta. We're talking about theta again. So it's not going to be the measure of the arc divided by 360. In trig, we're talking what? What's the measure of the arc come from? In trig, theta over 360. I'm just referring back up here to this formula. Times pi r squared over 1. Let's keep doing some trig thinking, substituting some things out. Get rid, okay, hold on, because it could be that arbitrary circle, okay? So we can't throw in that 1 unless we're told it's a unit circle. But you did say that we can do what with 360? Change it out with what? To 2 pi. So theta over 2 pi times pi r squared over 1. Where am I going with this, y'all? We're deriving again. Cancel what? Cancel the pi's. And what's that leave us with? Okay. Theta r squared divided by 2. You guys don't want to fool with fractions, right? You don't want to fool with a numerator and a denominator. How about let's make it this? A sub s is equal to. Isn't the coefficient of all of that 1 over 2? Can't I say 1/2 times theta r squared? Right? Isn't that nicer? I think that's nicer. I don't want to have to divide everything by 2. That's on your card. Okay? This is the area of the sector. Theta represents the what? The angle in what? It's what? The central angle, but it's in terms of radians. There we go. Central angle measure must be in radians. Pardon me? You can put that on your card if you can write it tiny. But I'm telling you, if you were to look at my card, your attention from talking. Here we go. Find the area. Let's got it on your card, right on? Theta is always in terms of what? Radians. No matter what we put into theta or what we get out of theta, it's always in terms of what? Radians at a class. Here we go. Look at this problem. Find the area of the sector with central angle of 60 degrees and radius is 10 meters. What's the first thing that I'm going to have to do? Draw it. It's not going to hurt you. I promise. Draw my same angle for all the angles. 60 degrees. What else am I given that I can put into my picture? 10 meters, which is my radius. And how do you know? This is what boggles my mind too. People use the wrong formula. They don't know what formula to use. Okay. Rate the problem. Rate it. Rate it, Tucker Brown. Rate it, Tucker. It does say sector. Yes, this one says sector. The other one said what? Arc length. Oh, that's what happens when you read the problem. You need to read it. That was kind of Forrest-like. Read it, Jenny. The area, the area of the sector. What's the formula? Write the formula. Always 1/2 theta r squared. Y'all are fart faces. I'm just saying. Not all of you, but a whole bunch of you. Not Whitney. Not Whitney, though. Not a fart face. I don't care. You still won't watch it, so it doesn't matter. So, here we go. Area of the sector. 1/2 theta r squared. Now, anything going on? What? Anything you seeing? Are we just going to jump right in and throw numbers in our formula? No, good. No, dude, they're in degrees. What do we have to do? You're right. Convert. Yes, convert. Now, 60 degrees. Now, some of you should not have to do this. 60 degrees. Pi over 180 degrees. You ought to know that that's pi over 3. You ought to know that. But you do have to convert it first. And it's good to have it in your notes because it's just going to be a reminder that, dude, it's in degrees. Okay? You can't put that in there. But I can put pi over 3. And my radius is given. It's 10 squared. I'm going to have 1 times pi times 10 squared is 100 pi, isn't it? 2 times 3 times 1 is 6. Have you ever seen anything, ever cut carpet to go in a room the size of 100 pi over 6 meters squared? What? Dude, no, you haven't. Liar! What? Fart face. Here we go. Take your calculator and calculate. Because what else do you do with a calculator? Cynthia. Sorry. Dude, that was great. I may go back and listen to this video. 100 pi. Here we go, guys. Do what? Probably so. I don't even care. Hey, what's your best answer? 52.4 what's? Wrong. Wrong. What? What squared? Meters squared. There we go. And that's another common mistake. Excuse me. Psst. That's another common mistake is that you don't know what you're solving for. Degrees, radians, no. Meters squared, we're solving for area. Okay? Fossil? All right, here we go. I see. No, no, no. Dude. Here we go. Check this one out. The central angle is 135 degrees. The radius is 9 meters. Find the area. Of the sector. Do this real quickly for me, please. You're on your own. How many of you got approximately 95.4 meters squared? Good, guys. High five. Good job. Questions at all? Remember, every value you put into theta, every value you get out of theta is going to be in terms of radians. And I know I say that every single problem, but you're going to have homework problems, folks, that are not going to be so cut and dry. You're going to be given the sector area and maybe the central angle, and you're going to be told to find the radius. And folks, it's just algebra. It's solving an equation. That's all. Okay? One more problem. Any questions on this one at all? Last one. Is this example what? Okay. Here we go. This has got it all. Star this problem. The area of the circle equals 36 meters squared. And you better read that carefully. It says to find, bless you, find the area of the sector of this circle that subtends a central angle of 120 degrees. Now this is a different one. This is definitely star-worthy. The area of the circle is 36 meters squared. Find, what are we finding? We got to find the area of the sector. All right, so that's my clue. A sub s is equal to 1/2 theta r squared. Do you guys agree with that? That's what I'm finding. Dylan, what you thinking? I can see the wheels turning. Nope. What are you seeing? No, we can't do a proportion on this. There's something that we have to know. There's a piece of information here that we need to be able. Okay, the area of the circle, the whole thing is 36 degrees. Pardon? Oh, okay. Let's see what we got. This is important to us. Area of the circle is 30. That's important. We're given that the central angle is 120. All right, ding, ding, ding. That's in degrees. What is that as a radian? If you don't know, then we got to convert, right? And then what's 12 divided by 18? Is it 2/3? Yeah, 6s. Do you guys agree with that? 60 goes into 120 twice. 60 goes into 183 times. So now we've got look at what we have. We've got to find a sub s. That's what we're looking for. 1/2 times 2 pi over 3 times the radius. What's radius? What? How do we not have one? It's not there. But we are given. Okay, this is the point where you don't panic. This is the point where you don't do this. I'm not doing this problem anymore. I'll go see her in the morning. You don't do that. You don't throw your pencil down and give up. What are you given? Oh, I have the area of the whole circle. What is the area of a circle? What is that formula? Pi r squared. And we know that that area is what, y'all? It's 36. So I can say that 36 is A, right? What will that allow me to find? Oh. How am I going to solve for the radius? Divide by pi. This looks weird, but it's totally doable. I've got to solve for the radius, correct? But do I need to solve for the radius? Anna, it looked like you recognized something. Look at this, y'all. Look. We have the radius squared. It's 36 over pi, right? What do we still have to plug into over there? We've got to plug in r squared. Do we know r squared? Yes. If my highlighter tool worked, which it never does from up here, I don't know why. Yeah, see? Doesn't work. Sucky, sucky smartboard. I have r squared. You just saw, how many of you, including myself, would have gone square root, found the radius, Miss Perry? How many of you would have done that? Because I would have. I'd have totally done it. You bunch of tree people. We are all tree people, y'all. We are not forest people. Step back and look. That's all we need. You are a tree person. Don't deny it. Did you see it? You did? Okay, you're a tree. You are totally a tree. You have always been a tree. R squared, 36 over pi. Guys, look at this. Mathematically, what's going to happen? You bunch of trees. What's going to happen? The pi's cancel. What else cancels? The 2's cancel. What else cancels? Oh, I could cancel the 3. 3 goes into 3 one time. 3 goes into 36. 12 times. Is it just plain old 12? Oh, look at her. Jacques Cousteau. Oh, ho, ho. You're right. Folks, don't be a tree person all the time. My toes right now are bent underneath my feet when I say that because y'all know I'm totally a tree person, okay? I'm stepping on my toes, okay? This, yes. Folks, if you step back and look at it, you don't have to work all the way through this. If you recognize, hello, we have it right here, then keep solving. And we get 12 meters squared for that area of the sector. Now think about it. 120 degrees related to 360 degrees. What portion of 360 is 120? Think about, all right, think. You got 360 degrees, right? What fraction is, how much is it? It's 2. It's 1/3, isn't it? What's 1/3 of 36? What's 36 divided by 3? Look at your answer. Because that would not be fun. That would be, nope. It would be cheating in a good way. If you recognize that, I'm just saying, I just showed you, I know you'll all go back and watch this portion of the video, that 12, if the area of a sector is a portion of the circle, isn't 12 a portion of the area, which was 36? Ah, it'll click. It'll click. Here's what you got to do. Here we go, page 184. 41 through 46. 48, 49. 51. 56, 58, 60, and 61. You got this. Okay?